Hello everyone. Okay, so in this video we are going to be looking at the modulus and modulus equations. So we're going to be looking at graphs of modulus and modulus inequalities in later videos. In this video we're just focusing on the idea of modulus and then solving equations involving a modulus. So what is the modulus? I am so glad you asked. So the modulus or absolute value, so that's another way we say the modulus of a number, is the positive value of that number. So the modulus of x is written as line x line. So this is these lines here, that's called my modulus. So it just means anything that's in my modulus becomes positive. So the modulus of -3, well, that becomes 3. The modulus of 4, that becomes 4. The modulus of -2x, well, that becomes 2x. You know what I mean? So anything that's negative within my modulus becomes positive. So a modular equation is an equation of the form x plus a modulus equals b. We have two methods for solving these equations, right? So method one is, this only works if I have one modulus, right? I isolate the modulus, so the thing in my brackets, and I let it equal to plus b and I let it equal to minus b. So like for example here, if I have the modulus of x is equal to 3, well, therefore, x has to equal -3, or x has to equal positive 3. So within my modulus, it has to equal -3 or 3. They're the only ways I can get 3. So, and if I have even more, if I have an equation inside, like x plus 1 is equal to 4, well, x plus 1 has to equal positive 4, or x plus 1 has to equal -4. So that is going to be x is equal to 3, and that's going to be x is equal to -5, right? So, and then we solve for both possibilities. So what we do here basically is, if I have an equation, x plus a is equal to b, I just have x plus a is equal to b, x plus a equals minus b. Bada boom, bada bing. That's it, right? But that only works if I have an equation in this form. If I only have one modulus, that's when it works. Method 2, we isolate the modulus, and then you square both sides, and then you solve the resulting quadratic. So for modular equations with two modular terms, we must use the second method. So I'm going to do method 1 and method 2 for this one here. So method 1, x minus 8 is equal to 3. Well, x minus 8 is going to equal to plus or minus 3. So x minus 8 is going to equal 3. X is going to equal to 11. And then x minus 8 equals -3, and x is going to equal to 5. So there are my two solutions there. Or I can look at method 2, and that is going to be x minus 8 squared is equal to 3 squared. This is going to expand out to x squared minus 16x plus 64 equals 9. Bring the 9 over. I have x squared minus 16x 64 minus 9 is 55 equals 0. Two numbers to multiply to get 55, but add to get 16. That's going to be x minus 11 and x minus 5. So x is going to equal 11 and x is equal to 5. So there are the two ways of doing it. So this one here is a double modulus. So I have two modulus here, so I have to use my second method of squaring what's in my modulus. So I have the absolute value, or the modulus of x plus 1 is equal to the modulus of x plus 5. Square both sides. X plus 1 squared equals x plus 5 squared. This expands out to x squared plus 2x plus 1. X plus 5 all to be squared is going to be x squared plus 10x plus 25. Bring everything over to one side. Happy days, this one doesn't end up being a quadratic. So bring everything over to one side. X squared minus x squared 0. 2x minus 10x is minus 8x. And then bring the 1 over here. 25 minus 1 is going to be equal to 24. Divide both sides by minus 8. X is going to equal to minus 3. So that is when them moduluses are satisfied. So if you sub it in here, minus 3 plus 1 minus the modulus of minus 3 plus 5 equals 0. Well, that makes sense. This is going to be the absolute value of minus 2 minus the absolute value of 2. So it's going to be 2 minus 2 equals 0. 0 is equal to 0. So that solution checks out. So, right, let's look at some exam questions now. So the first one here, 2023, comes from the Leaving Cert high level paper. So this was the first question of the paper last year. Find the two values of m elements or for which the absolute value of 5 plus 3m equals 11. So I have 5 plus 3m is going to equal to plus or minus 11. 5 plus 3m is equal to 11. 5 plus 3m is going to equal to minus 11. 3m is going to equal to 11 minus 5, which is 6. M is going to equal 2. 3m is going to equal to minus 11 minus 5, which is minus 16. And m is going to equal to minus 16 over 3. And they are my two solutions there. So you can double check your answers by subbing in. So 5 plus 3 times 2 is 11, gorge, and that'd be 5 plus minus 11 thing, gorge. Method 2, if you want, it's going to be 5 plus 3m all to be squared is equal to 11 squared. So 25 plus 30m plus 9m squared equals 121. 9m squared plus 30m. 121 minus 25. What's that? Who knows? Who knows? 25 minus 121. That's going to be minus 96 equals 0. I can divide across by 3. So I have 3m squared plus 10m minus 32 equals 0. 3m here, m here, and then this is going to be minus 2, and this is going to be plus 16. Then again, 3m plus 16 is equal to 0, m minus 2 equals 0, 3m is equal to minus 16, m is equal to minus 16 over 3, m is equal to 2. So there you go, there were the two ways of doing it, and I got the exact same answers. Let's look at this one. This is from the 2021 paper. So given that x equals minus 3 is a solution to x plus p is equal to 5, find two values of p, where p is an element of the integers. So it's a whole, positive or negative number. So if you got a fraction for p, you might want to go back and check your answer. So we know x equals minus 3 is a solution. So I'm going to have minus 3 plus p is equal to 5. And gorge, now we have a regular modular equation. So I can say minus 3 plus p is equal to plus or minus 5. Minus 3 plus p is equal to 5. Minus 3 plus p is equal to minus 5. P is going to be equal to 8. P is going to be equal to minus 2. There are my two solutions there. Or you do minus 3 plus p squared equals 5 squared. This is going to be 9 minus 6p plus p squared equals 25. P squared minus 6p, 9 minus 25 is minus 16 equals 0. Two numbers to multiply to get minus 16, but add to get minus 6. That's going to be p plus p minus 8. And p plus 2 equals 0. And p is equal to 8, and p is equal to minus 2. Bada boom, bada bing. There you go. So that was method 1, method 2. Doesn't matter which one you use, as long as you do it correctly. Right. Now, this one here, this is some exam style practice ones. So solve for x. The modulus of x minus 2 is equal to 3. Easy peasy. So x minus 2 is going to equal to plus or minus 3. X minus 2 is going to be equal to positive 3. X minus 2 is going to be equal to minus 3. X is equal to 5. X is equal to minus 1. Bada boom, bada bing. Easy peasy, lemon squeezy. Or again, we could use the quadratic method for that one. This one here, the modulus of 3x plus 9 is equal to the modulus of 2x plus 1. So this is, we have the double modulus here. So it's going to be 3x plus 9 squared. We have to use method 2. Equals 2x plus 1 squared. Multiply this out, I get 9x squared. 54x plus 81 equals 4x squared plus 4x plus 1. Gather my like terms, everything over to one side. 9x squared minus 4x squared is going to give me 5x squared. Minus 54x minus 4x is 50x. 81 minus 1 is 80 equals 0. I see here I can divide every term by 5. So I'm going to have x squared plus 10x plus 16 equals 0. I have a quadratic here. Two numbers multiply to get 16, but add to get 10. So I have x plus 2 and x plus 8. So my two solutions are x equals minus 2 and x is equal to minus 8. And there are my two solutions there. So you can check your solutions by subbing in. If I sub in minus 2 up here, I'm going to get minus 6 plus 9, which is the modulus of 3. Here I'm going to get minus 4 plus 1, which is minus 3. And the modulus of 3 does equal to the modulus, or the absolute value of minus 3, as 3 equals 3. Anyway, always check your answer by subbing in. Now finally, this one here is a bit of a nasty one. So I have fractions. So I have x plus 2 over 5, and the absolute value equals the absolute value of x minus 1/3. So that is going to be x plus 2 over 5 squared equals x minus 1/3 squared. So multiply these out. I'm going to get x squared plus 4 over 5x plus 4 over 25. If you're wondering, oh my god, he did that so fast. Perfect squares, remember? Perfect squares, a plus b squared equals a squared plus 2ab plus b squared. A squared is x. 2ab is 2 times 2 over 5x, which is 4 over 5x. And then finally, b squared, 2 over 5 squared is 4 over 25. That's going to be equal to x squared minus 2/3 x plus 1/9. Right, so, going to be left with some fractions here. But, oh, handy dandy, the x's are going to cancel out. So that is, the x squareds are going to cancel out. So that is nice, right? X squared minus x squared is going to give me 0. So I'm going to have here 4 over 5x plus 4 over 25 equals minus 2/3 x plus 1/9. Now I'm left with a regular equation. So I can just gather my x's here. So 4/5, oh crazy, 4/5 x plus 2/3 x equals 1/9 minus 4/25. My left hand side is going to be, so 12 over 15x plus 10 over 15x equals, oh my god, what does 9 and 25 have? Use your calculator. Use your calculator. Don't be a hero. Don't be a hero. Just use your calculator, okay? Like, I'm sorry, who could be doing 1/9 minus 4 over 25? Like, that's ridiculous. I'm sorry. No one will be doing that in their head. If you actually know, if you can do that in your head, you're probably not watching this video anyway. You probably don't need it. Minus 11 over 225. Add these together. 22 over 15x equals minus 11 over 225. 22x is going to be equal to multiply both sides by 11. I'm going to multiply both sides by 15. I'm going to get minus 11 over 15. and then divide both sides by 22. My answer here is x is going to be equal to 1 over 30. How fun was that? Hate fractions. Right. Anyway, but there you go. There are just some questions on the modulus. Next video, we're going to be looking at graphing the modulus and then using graphs of modulus to solve modular equations. And then finally, in the last video, we're going to be looking at modulus inequalities. I hope this video was some help to you guys, and I'll catch you guys later. Bye.